Hello everyone. So today let's solve the problem number 721 accounts merge, right? So let's see what the question states here. So we are given multiple accounts here, each with a name and several emails, right? 1 second. Sorry. Here, 1 second. We are given multiple accounts, each with a name and several emails. See here, John, John Smith at mail.com, John New York, John New York at mail.com. So again, John, yeah, John Smith at the mail.com. This one, John 00 at mail.com, and Mary at the mail.com, and Johnny Bravo at the rate of mail.com. Right. So the output that we need to get here is this one. This is fine. Yeah. Now let's see what the question states here. Right. So further, right. Let's move on further. Basically, we are given multiple accounts, each with a name and several emails. If two accounts share at least one common email, they belong to the same person. If two accounts share at least one common email, they belong to the same person. We must merge such accounts so that each person's combined emails appear exactly once, right? So after merging, email should be sorted lexicographically, right? So we must merge such that the such accounts, such sorry, so that each person's combined emails appear exactly once. This is important actually. After merging, email should be sorted lexicographically, right? So we have to return all the merged accounts in any order they have given, right? So here I've just shown you the example actually. Here, first what we will do, let's do one thing. We can just go with the DFS one for this approach. So we can just go with the DFS or the BFS, it doesn't matter. So in simple terms, we can just go with the BFS or the DFS along with the this one. What do we call? Sorting. A bit of we need sorting here. So let's discuss the approach here. So I'll just directly discuss the approach for the exam by considering example one. You can just implement the same thing for the, or you can just consider the same thing for the example two actually. Yep, you can do the same thing. First, what we will do, we'll treat each email as a node in the graph. We'll treat each email as a node in the graph. So this one will be one node, and this one will be another node. This one will be one node, and this one will be other node, like that, right? So we will treat each mail as a node in the graph. If two mails appear in the same account, then we will connect them. If two mails appear in the same account, then we will connect them. See here, let's connect this one. Let's connect this one. Actually, if two mails appear in the same account, then we'll connect them. So this is undirected graph, not the directed graph. It can be connected from this mail to this mail or this mail to this mail. Undirected graph, right? So this is fine. I hope this is clear. So again, we'll just connect the two mails, right? If two mails belong to the same person, actually. This one and this one. Suppose, just for example, we'll be connecting this one. These are the two nodes actually, node one, node two. We have connected this one via so this one connected this one. This is nothing but the undirected graph. This way, all connected emails form one connected component. This way, all connected emails form one connected component, one merged account actually. Right? So we will be making use of the DFS or the BFS to find all the emails connecting to each starting email, right? So finally, we will sort those emails and add the corresponding name exactly once. Yeah. So this is the approach that we will be going with. Yeah. So output will be same. This one, John, this one, right, along with this one, uh, and this one, John Smith at the rate of mail, and Mary. So this one again, the John, the different email, this one, yeah. So output will be same. So let's do one thing. Now we have discussed the approach, right? So before hopping into writing the code, let's do one thing. Let's quickly discuss the complexities part actually, right? So what will be the time complexity here? Time complexity. Let's go with the DFS as well as the this one. For this particular problem, let's go with the DFS along with the sorting one. So overall time complexity would lead to big O of n into m into log m. You would have already guessed, right? You would have already guessed. It is big O of n into m into logarithmic m. right? So n is nothing but the number of accounts, m is nothing but the max emails per account, nothing but log m for sorting this one each component, right? Overall, it would lead to big of n into m into log m, right? So what would be the space complexity here? Space complexity would be big of n into m respectively. Why it is big of n into m? So because for the graph, we'll be considering adjacency list and visited set both, right? So overall, it would lead to big of n into m space complexity. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into m into log m and big of n into m respectively, right? So now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Let's start writing the code. Yep. So first step here, let's go with the hash map, man. Let's map each mail to its corresponding username, right? So I'll just go with map here, map. So this one will be string, comma. I'll just go with the string. So this is also fine. I'll just go with name map. So this one will be new hash map. Yeah, new hash map. So this is fine. The second step would be, let me go with the map. So this is also fine. I'll just go with a string. Uh, yeah, let me go with the list of actually string. This is also fine. Mm, let me make use of the graph helper method. Sorry, variable name graph. Let's go with the graph. So this one will be one more hash map. Let me complete the syntax here. This is fine. What was the step one actually? So we have to build the graph connections, right? Now let's go with the simple for loop here, iteration part. So this will be list of string. This is fine. Mm, a double C of accounts actually. Where is accounts here? Let me copy this one and let me paste it over here, accounts. So within this for loop, let's do one thing. I'll just go with the string name. So this one will be account dot get of 0. Yep, so this is fine. So this is just the person name. Let's go with the for loop here. So this one int I equals 1, I less than size. This is fine. Uh, then let me go with I plus plus. Yep, I'll just go with string email. So this one will be account dot get of I. So this is also fine. So next, let's go with this one. Let's map the email to the name, right? So I'll just go with the name map. We have considered name map itself, right? Oh, one second. Yeah, this one actually I was speaking of. Let me paste it over here. Name map. Let me make use of the put operation here. Let me pass email along with the email. Let me pass the name as well, right? So this is fine. We have successfully mapped email to the this one name. Now, let me go with graph dot put. Let me make use of put if absent here. Put if absent. So let me go with email. Along with the email, let me go with the new array list. New array list. So this is fine. Now let's move on with the further things actually. Let's connect this email with the first email of the same account, right? So if I equals 1, then we have to skip. So I'll just make use of the continue keyword here. So again, string, let me go with the first here, account dot get of 1. So this is fair. And let me make use of graph dot get here. So let me pass first, yeah, first dot add of email. So this is fine. Let me copy the same thing here, copy paste. Graph dot get instead of the first, let me go with the email. So this is fine. Add mail. So I'll just go with the add of first actually. This is fine. So let me come out of this one entirely. Now let's move on with the let's go with the DFS just to find the connected components or the merged accounts, right? So I said we can go with the BFS as well. So let's go with the DFS itself. Yeah. So before going with the DFS actually, let's do one thing. Mm, yeah. Let's write the helper method DFS man. Yeah. Let's write the helper method DFS. Then we can continue this one. What do we call? Continue the code within the this one main method actually. right? So I'll just go with a private void. So let me go with DFS actually. What are the things that I need? E, which is of the type string, and let me go with a map string here, and also list actually, list of string. So this is fine. Let me go with G. This is also fine. Let me go with set. Let me go with a string here. So this is also fine. Visited BIS. Now let me go with the list actually. Let me go with string. So this is fine. See, we need the components, right? I'll just go with a comp here. So this is fine. I hope this works, man. Let's see. So I'll just add this one edge to the visited actually, if it is right. So let me go with the comp here dot add. Let's add that particular edge. So next, let's write the simple for loop here. Let me go with neighbor, individual neighbor of graph g actually, g dot get of edge. Within the for loop, let's write the simple if condition. If not of visited dot contains actually of neighbor of neighbor. So let me do one thing. I'll just go with the DFS of this one individual neighbor G. Let me go with the visited as well as component CYMP. So this is fine as well. Yep. So yes. Let me format the code one. So this is it for the DFS actually helper method. So this one we have to make use of it within the this one, right? Main method. So let's check the same actually. We are left with here dot get. So let's do one thing. Let's continue from here. Yep. Let's go with the DFS to find the connected components. Nothing but we have to go with the we have to we have to go with the merged accounts actually. So I'll just go with set. So let me go with the string here. Let me consider variable name visited. So let me go with new hash set. So this is also fine. Yep. So the next step would be let me go with the list here. List. I'll just go with the list of string. Yep. So this is fine. Let's go with the resulting variable res new array list. Yep. The next step, let's move on with the iteration part. So this one will be for string email of graph dot set actually. So this is fine. Yep. So within the for loop, let's go with a simple if condition. If of not of visited actually dot contains of let me pass the email now. So within the if condition, let's go with the list actually, list of string. So this is fine. Let me assign this one to the new array list actually. Yep. So this is fine. Next step, let's make use of the DFS. So the this one helper method that we have written here, right? So DFS of what are the things that we need to pass here? One is email, another one is graph. Also, let me go with visited and let me pass the component CYMP as well. Yep. Now let's do one thing. We have to sort the emails this one alphabetically. So let me make use of collections here dot sort of I'll just go with the component COMP. So this is fine. Now let's add the name at the front, nothing but COMP dot add. We have to add the front, so we have to go with 0 here. Let me go with the name map. So let me type here instead of searching for it. Just go with dot get. Let me pass the email over here, right? Finally, let's go with result dot add. What we need to add to the result component COMP, right? So this is fine. All we have to do now is we have to return the result. We have to return the result. So it will be the result will be stored in the resulting variable res, right? So yep. Let me format the code and let me hit the run button. I hope this works, man. Mm, Map of string class map. We have to go with a capital M here. Where is this actually? Yep. So let me go with a capital M here. Let me hit the run button. So here new hash map H has to be capital here. Line number 4. 1 second. Yeah. Now this is fine. Let me hit the run button. This has to work now. Let's see. We have cleared both the errors, right? Yeah. The sample test cases are getting passed here, right? So it we can easily solve this one with a BFS as well. We can just try to solve with the this one BFS as well. It can be easily solvable by BFS. Yeah. So I just previously before the DSU we solved the problems on BFS. I think that is the reason I just wanted to make use of the this one DFS actually. If we solve one problem with the BFS, next let's solve any other problem. So it can be if it can be solvable either by DFS or the BFS. Let's go with this one alternative ones. First, if we would have, I mean, if we have solved or if we had solved the previous one on the DFS and the next problem, if it can be solved by either by BFS or the DFS, let's go with the BFS, right? So we don't have to implement the same thing, DFS again, right? So let's go with the BFS. So in my opinion, the last problem we solved on the DSU, that is fine. That is completely fine. Disjoint unit set. Before that, we actually implemented BFS, I think, right? So that's the reason I chose DFS, right? So this is fine, man. Now let me hit the submit button. I hope this works for all the test cases, man. Yeah, let's see. So you can clearly see here, all the test cases are getting passed. So whatever the code that we have written works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.